Chapter 3, Exponential and Logarithmic Function. 3.1, Exponential Functions. The learning objective is to solve an exponential function. Okay, we want to solve. Introduction. Other functions with many applications in technology and science are the exponential and logarithmic functions. So we are focusing about exponential in this topic. Okay, exponential functions are used in electronics, mechanical system, thermodynamic, nuclear physics, biology, in studying population growth, and in business to calculate compound interest. A polynomial function and exponential function. This note shows us the difference between polynomial. Okay, the regular function that we have seen earlier, for example, is x power of 3. But for exponential, the x is located at the subscript, at the exponent. So we call this kind of function as exponential. When you see x, or when you see any variable on the exponent part, on the power part, hence it is called as exponential function. An exponential function has the variable in the exponent, not in the base. So as shown here, the x is located in the exponent, not in the base. The general form of an exponential function is given by f(x) equal to n power of x. See here, the variable x is in the exponent. X is the independent variable, is the power or exponent. So there are two types of trends in exponential. We have two types of behavior, which are growth and decay. Okay, exponential growth and decay. An exponential function f is given by this general form, f(x) equal to b to the power of x. See here, x is located in the exponent as the variable, where x is any real number, b greater than 0 and b is not equal to 1. Okay, the first type of behavior is growth. And the curve that represent of growth is represented by this orange curve. Okay, where it comes from small value and it increase and increase. So we call this as exponential growth. It is indicated by the value of b. If b greater than 1, hence we will get the growth function. On the other hand, if b is less than 1, okay, if b less than 1, the behavior is exponential decay functions. And the curve, the green curve, represent the decay function. Okay, so the types or the behavior of exponential function depends on the value of b, the coefficient that has power x. If b value is less than 1, we will get decay, and if b greater than 1, we will get growth function. Okay, next is about properties of exponent. You can get this from the mathematical formula book, page 7. Okay, so this all about the exponent. Okay, let's go through one by one. Okay, number 1, a power of m times a power of n. Okay, this is multiply, and if we have the same base a and a, we can combine the index by putting addition sign, so it equals a power m minus n. In contrast, if the operation is divides, okay, a power of m divides by a power of n, means that the index or the power should be subtracted. Here the power become m minus n. Number 3, if you have a bracket and outside of the bracket you have power n, and inside the bracket you have element and has its own power. Okay, so how to solve this? This means that the index can be multiplied together, so it becomes a power m times n, a m n. Number 4, if you have a bracket and you have a power outside of the bracket, in the bracket you have two elements. So based on this rule, it shows that each element gain the same power. So A has power n and B has power n as well. Number 5, if the index in terms of fraction a to the power of m over n, it equal to a power of m and square root of n. And you can also put the square root inside the bracket and put m on the outside. So this rules shows that the power of fraction can be written in terms of square root. Now the next rule, number 6, a to the power of 0 equal to 1. Any number that has 0 power, it equals to 1. Number 7, a over b, and you have a big bracket and you have power outside. This equals to each element with its own power, so a power of m over b power of m. Next, if you have negative index, negative power, a negative m, it equals to 1 over a power of m. Number 9, a to the power of 1 over n can be written as the square root of n. So these 9 rules should be understood by the students, okay, and you have to know when to apply. Right, now let's look at example 1. Simplify. Question A. 11 power of 7 times 11 power of 9. Okay, so this equal to 11 power of, you must plus the index because we have used multiply sign, so it becomes 11 to the power of 16. B, you have 7 power of 8 divides 7 power of 3, it equal to 7 power 8 minus 3 and equals to 7 power of 5. C, okay, we need to apply the rules, since here we have a power inside the bracket and outside of bracket we have another power, means that you have to multiply, so it becomes 3 to the power of 24. Alright, question D, inside the bracket you have 2 elements and outside of the bracket you have power, so each element gain the same power, so it is 125 u power of 3. Question 2, simplify. Question A, 8 power of 5 square root of 3. We can write like this, or you can bring the power of 5 outside, so inside the bracket is just this one. The square root of 3 for 8 is 2, so 2 power of 5 equals to 32. 2b, 253 power of 0, we know that everything that has power 0 equal to 1. Question C, you have fraction and outside of the fraction has power, so each element gain the same power, so it equal to 9 over 16. And for the negative index, it equals to 1/8 power of 2 equal to 1 over 64. Example 3, simplify. Okay, for this part you have to multiply together. Look at the number first, 3 times 2 equal to 6. And now you have to collect the same variable, for example x with x. So now here you have x, since the first element has power 2 and another element has power 1, so 2 plus 1 become x cubed. For the y, 3 plus 5 is 8. So this is your answer, 6x cubed y to the 8. Now question B, look at the number first. For 8 is 1 over 2. And for a variable, we have 5 and 1 at the bottom, so 5 minus 1 is 4. For B, you have 3 and 2, so b power of 1. For C, 1 minus 4 is minus 3. You can also rewrite like this, a 4b over 2c3. Okay, this is the same answer. Okay, now number 4, how to sketch the graph of exponent. Okay, how to sketch is by using a table. Okay, by using a table, you need to insert some value of x and the corresponding value of y. Let's take some negative value. I start with negative 10, negative 1, 0, 1, 2, 3. And by putting this x value into y, you can calculate each one of it. So for negative 10, it is equal to 1.69 times 10 to the power negative 5. This one 0.3, if 0 is 1, if 1 is 3, x2 is 9, x3 is 27. After we fill in the tables with some values, you need to plot. Okay, so at negative 10, you get the small number 10 to the power of minus 5. It's very small, close to 0. So on the labeling, on the plotting here, you can plot close to 0. Minus 1 is 0.3. 0 is 1. 1 is 3. 2 maps to 9. 3 to 27. 27 is not in the screen here. So we know that the pattern on the right hand side is increasing like this exponentially. It increasing sharply, right? While for the left hand side, it approaches 0 but not touch 0. So it only approaches 0 like that. So this is the graph of exponent 3 to the power of x. And we want to label the vertical axis as y and this one as x. Okay, so this is the sketching of graph y equal to 3 to the power of x. Next, we want to answer the domain. The domain is the value of x. The curve can be extended to the left and to the right. So the minimum value of x can be negative infinity and the maximum of x can be infinity. So that is the answer for domain. While on the range, look, the curve is only covered at the positive side. So the minimum value is 0, but it not touch 0, and it will go to infinity, open bracket at infinity, as 0 is also open bracket because 0 is not included. Okay, so that is the answer for the range for y equal to 3 to the power of x.